Hello everyone. The title of this video is Writing Equations of Hyperbolas Not Centered at the Origin in Standard Form. Alright, so in this video, I'm going to be going over examples taken directly from a free online textbook at openstacks.org. I'm in their Algebra and Trigonometry text, section 12.2, called the Hyperbola. And I'm under the heading, hyperbolas not centered at the origin. Right, so examples I'm doing in this video are going to be either examples from the reading or try it problems from the reading or one of the exercises at the end of the section that's related to this particular objective. Alright, so I'm assuming that you've already seen my video on writing equations of hyperbolas centered at the origin in standard form. So I'm assuming you're familiar with the standard form equation of a hyperbola centered at the origin. All that changes when the hyperbola is not centered at the origin, it's centered at some other point, say with coordinates h and k, is that the x is replaced by x minus h, and the y is replaced by y minus k in the equation. So here in this box here, we've got the standard forms for the equations of hyperbolas centered at the point hk. So if the transverse axis is parallel to the x-axis, or if the transverse axis is horizontal, meaning the two curves will open to the left and to the right, so this left picture here, see the two curves of the hyperbola, the two branches open to the left and the right, the transverse axis is horizontal, then the equation in standard form will look like this. You have some quantity x minus h squared divided by a squared minus the quantity y minus k squared divided by b squared equals 1. It's once again a difference of squares equals 1, and if the transverse axis is horizontal, the x squared term will be the positive term. Now, the a and b in this, right, h and k represent the coordinates of the center. A and b represent the same thing they did last video. A represents the distance from the center to a vertex, right, and there are two vertices. So you're seeing here from the center hk to these two vertices, right? The vertices were the points on the hyperbola that were closest to the center. That distance is a units, the distance from the center to a vertex. And then you have these co-vertices that aren't on the center, aren't on the hyperbola, that are not solutions, but they're helpful guides. These things called co-vertices that are b units above and below the center, right? That's what b represents. B represents the distance from the center to those co-vertices. And once you have the co-vertices and the vertices in, you can make this little rectangle. You see this dotted rectangle here that goes through the co-vertices and the vertices, and then through the corners of that rectangle and through the center go the asymptotes, which the asymptotes in this case, when the transverse axis is horizontal, the slope will be b over a and negative b over a, right? Rise over run. And you get the, and you should be able to write equations for lines by now. Right? And you're going to be asked to write the equations for these two lines, these two asymptotes that the curves will get closer to as you go further away from the center. And then there's these 2 points called foci. Sorry, see this h plus c comma k, h plus c, h minus c comma k. There's these 2 points that are on the same line as the vertices. There's these 2 points on the transverse axis that are inside the curves called the foci. And those are c units away from the center. And the relationship between c, a, and b for any hyperbola is right here, where my cursor's floating around. C squared equals a squared plus b squared for any hyperbola. And the special thing about the foci is the following. if you take any point on the hyperbola, any point on this curve or this curve, it doesn't matter. Take any point, take the distance to one focus and the distance to the other focus and subtract them. Find the difference. It will always be 2a. It will always be the distance, same as the distance between the vertices. All right. No matter what point you pick, the distance to one focus minus the distance to the other focus will always be 2a for any hyperbola. That's why we're finding the foci as well. Okay, so that was, when the transverse axis is horizontal. When the transverse axis is vertical, all that changes is the x minus h and y minus k switch. So it's y minus k squared over a squared minus x minus h squared over b squared equals 1. And in this case, the vertices are above and below the center, right? And the curves open up and down. So that's this picture on the right, picture B. A units up, A units down for the vertices, B units right and B units left for the co-vertices. You make the rectangle, you make the asymptotes, you draw the rest of the thing in, the rest of the hyperbola in. And this time the slopes of the asymptotes are A over B and negative A over B, right? Because the rise is A and the run is B now, right? And again, you should be able to write equations for lines. And the same thing for C. C squared is equal to A squared plus B squared. And then once you find C, you can find those foci, which are on the transverse axis. So they'll be above and below the center as well. All right, so now that I have all this, that should be enough. And again, if you've seen my video on writing equations of hyperbolas centered at the origin, that should be enough information to be able to, get us through these examples. All right, so the first example I have, and in all the examples, we're going to be either given some information about the hyperbola or a graph. And I think my last example is a graph of a hyperbola. And then we're just going to be asked to write the equation in standard form for that hyperbola. All right, so in example 1, I'm given the vertices and the foci. And I'll start drawing this stuff off to the side. So here's the xy plane. And the vertices are at 0, negative 2, and 6, negative 2. Right. And I'll make these green or something. You probably can't tell what color this is, but 0, negative 2, and 6, negative 2. There's the vertices. And remember, the vertices are actually on the hyperbola curves. Right? They're actually solutions of the equation we're going to write. Now this tells me right away that the transverse axis is horizontal. See how the vertices are left and right of each other? If I drew a line through these, that's a horizontal line. And the line through the vertices, that's called the transverse axis, right? The transverse axis is horizontal. And if that's the case, then the equation we're going to be writing is going to start with the x squared term, right? It's going to be, x squared minus y squared, but, it's going to have the x minus h squared divided by a squared minus then y minus k squared divided by b squared equals 1. This is the equation we're writing. The equation of this hyperbola in standard form is going to look like this. Now I just need to fill in some letters. I need to find h, k, a, and b. Well, remember the center, right? The center of the hyperbola, that's the hk. And if you know where the vertices are, or the foci are, or even the co-vertices, you'll know where the center is. The center is the midpoint of the vertices. So hopefully you remember how to find midpoints. Just take the average of the x-coordinates, the average of the y-coordinates. So the average of the x-coordinates here is 3, right, halfway between 0 and 6. And then the y-coordinate's always negative 2 here. So 3, negative 2. 3, negative 2. There's the center of this hyperbola. So when I go to write the equation, right, h is 3 and k will be negative 2. All right, and then we're also told that the foci are at negative 2, negative 2, right? And the foci should also be on the transverse axis. So there's, maybe I'll make this red. But these foci, right, here's a focus. Right, this is not actually on the hyperbola though. Right, it's just another guiding point. And then the other focus is at 8, negative 2. 8, negative 2. So there's another focus. Now that should be enough, right, to be able to write the equation to help me find A and B. Now A is simple in this example. The value of A is the distance from the center to a vertex. So the value of A is, what's the distance from 3, negative 2 to 6, negative 2? That'd be 3 units. Or from 3, negative 2 to 0, negative 2, that's still 3 units. So the value of A is 3, meaning that A squared is 9, right? And that's going to be the denominator under the x minus h squared term, or x minus 3 squared, right? Because h is 3. And then I also have from this picture, from the information given, I also know the distance from the center to a focus, and that was called c, lowercase c. So what's the distance from 3, negative 2 to 8, negative 2, or from 3, negative 2 to negative 2, negative 2, either focus? That's 5 units. So we know that c is 5, and if c is 5, then c squared must be 25. And then like the last video where the center was at the origin, right, it doesn't matter. For any hyperbola, c squared will be equal to a squared plus b squared. Again, remember, a is the distance from the center to a vertex. B is the distance from the center to one of those co-vertices. And I can use this relationship to help me find b squared. Right. So I pop in 9 for a squared, right? I know that a squared is 9. So now we have 25 must be equal to 9 plus b squared. Then to get b squared, I simply subtract 9. 25 minus 9 is 16, which is a nice number. So b is 4. But when I write the equation, right, b squared is 16. 16 is going to be in the denominator under the y minus k squared, or y plus 2, because y minus negative 2, y plus 2, k is negative 2. All right, but b is 4, so that's going to help me draw the rest of the hyperbola. 4 units from the, so from the center, I get the co-vertices, right? So go up 4, down 4, because again, the co-vertices are on the conjugate axis, which is perpendicular to the transverse axis. So from 3, negative 2, I go up 4, that would be at 3, 2. There's a co-vertex. And then down 4 to 3, negative 6, there's another co-vertex. Again, those aren't in green either. All right, the co-vertices are also not on the hyperbola. The only points I have drawn so far that are actually on the hyperbola are the vertices, 0, negative 2, and 6, negative 2. All right, but what I'm going to do is I'm going to use the co-vertices and the vertices to create a little rectangle. A rectangle going through that contains, these co-vertices and vertices. And then using this rectangle as a guide, we can draw the asymptotes. The asymptotes should be going through the corners of this rectangle and through the center. And sorry about the crappy, this isn't the greatest of drawings, but there's one asymptote. Here's the other asymptote. Now I'm going to do the equations of the asymptotes here on a separate page. Right. I want to eventually, and you're gonna have to do this as well, write the equations of these asymptotes. And I'll go to Desmos, that free online graphing calculator, in a little bit to see if my equations of the asymptotes are good. All right. Now, what I like to do is write the equations in what's called, point slope form. You should know how to write equations of lines. But both these points, both these asymptotes, go through the center, the point 3, -2. All right. So there's a point, and the slopes of these asymptotes are the following. So again, to find the slopes, it's real easy. To find the slope of this line here, just go from the center, which is a point, to one of the corners, which is another point on the line of the rectangle. So that would be what? I'd go, remember, up 4 and then right 3, right? B was 4 and A was 3. It's B over A here. 4/3. So the slopes are 4/3 and -4/3. They have opposite slopes. Right? So that means the equations of these asymptotes are the following. Y minus -2, or y plus 2. I'm putting it in point slope form here. You should know what this form is. You should know how to write equations of lines in this form. But y minus -2, or y plus 2, equals the slopes, which will be 1 will be plus, 1 will be minus, 4/3, times the quantity x minus 3. And then they're having you solve for y by just subtracting 2 here, right? Or y equals plus or minus 4/3 times the quantity x minus 3, and then minus 2. Right? They're having you write the equations like that. Right? And you'll see that in the assignments and whatnot, in the problems. All right. So one of them, the one with the positive slope, that's this one up here. So this one has the equation y equals 4/3 times the quantity x minus 3 and then minus 2. That's that line. Now you could also have just said y equals, you can put it in slope-intercept form if you want. Distribute the 4/3. It's just y equals 4/3 x minus 6. Right? The y-intercept is -6 there. But sometimes it's not always easy to see what the y-intercept is, so that's why I'm going to keep it like this. And then the other one is y equals -4/3 times the quantity x minus 3 and then minus 2. Okay. All right, now once you have the asymptotes and the vertices, right, you can make a rough sketch of the graph. Starting from a vertex, just kind of use the box and the asymptotes as a guide, and just make sure that the curve is curving outward, but toward the asymptotes, without actually touching the asymptotes. Right, the further away we get from the center, the graph will get closer and closer to the asymptotes. So these points I just drew, these are actually supposed to be solutions of the equation. These are actually part of the hyperbola finally. Right? And the same thing over here from this other vertex, drawing the curve that's part of the hyperbola. And it should be symmetric about the conjugate axis. If you reflect each curve about the conjugate axis, you should get the same graph again. Right? All right, and then finally the equation. The equation for this, just filling in values here. Remember, h was 3, k was -2. We saw a squared is 9, b squared is 16. So the equation of this is the quantity x minus 3 squared divided by a squared, right, divided by 9, minus, and then y minus k, which is y plus 2, right, because k was -2, squared, divided by b squared is 16, equals 1. And this, this is all finally what they wanted. Right. All right, and what I'm going to do is check this out. I'm going to go to Desmos and see if this graph looks anything like my drawing, if the vertices are correct, And I'll also plot the asymptotes, and because I want to make sure that my value of a and b are correct, and if the asymptotes are right, then I know I did that. Then I know I did that well. So back on the I'm going to desmos.com. It's a free online graphing calculator, and I'm going to put in the equation I just wrote. Quantity. I'm actually getting to one of the slots here. X minus 3 squared divided by 9 minus the quantity y plus 2, right, y minus negative 2 squared divided by 16 equals 1. Right, you see this hyperbola showing up. And I'll plot the center, right, which we said was at 3, negative 2. And you can very clearly see if that that's definitely halfway between these two curves. And then here's 0, negative 2, right, the one vertex. Here is 6, negative 2, the other vertex, right, the 2 points closest to the center. And those were the vertices they gave us. And now I'll plot the asymptotes, right? Now we have the hyperbola drawn. I'll plot the asymptotes. One of them was y equals, 4/3 was the slope, times the quantity x minus 3, x minus h, and then plus k, so minus 2, right? And I'll draw the other one. I'm just going to copy and paste this one and change the slope from positive 4/3 to negative 4/3, or just throw a minus in front of it. All right, and I'll change these up so that they're dashed lines in both the same color. Great. And it looks pretty good. Again, these asymptotes should both be running through the center, have just opposite slopes, right? Positive 4/3 and negative 4/3, and the hyperbola should be approaching these two dotted lines as we move away from center. So if you zoom out, if you scroll out, you'll see that the two curves will basically get closer and closer to becoming those two lines. See that? All right, and the further, you can zoom out far enough to where it basically looks like they are those two lines. Even though they're not, right? They're not. They don't actually touch those two lines, right? If you zoom in close enough, you'll see the blue curve doesn't, the hyperbola doesn't actually touch the asymptotes, but it gets as close as you want, right? It gets as close as you want. So those asymptotes look good. That means, my value of A, my value of B, that helped me find the slopes of these asymptotes. Those were correct, and this equation is correct. All right. Great, and I'm going to keep doing that. All right, next example is pretty similar. We're given some information about a hyperbola and asked to write the equation in standard form. And again, and I'll draw it out and stuff, do all the same stuff I just did. Right. So here, the vertices are 1, negative 2, and 1, 8. And I'll start drawing it over here. So 1, negative 2, there's a vertex, a point that's actually on the hyperbola, actually satisfies the equation we'll draw. And 1, 8. So 1, negative 10, or sorry, 1, negative 2, and 1, 8. Those are the vertices. So clearly, right, the transverse axis is vertical, right? The transverse axis is vertical in this case, meaning that the equation I'm going to write is going to be the one that starts with y squared. Right? It's a difference of squares equal to 1, but it starts with that quantity y minus k squared divided by a squared minus, and then x minus h squared divided by b squared equals 1. So we're writing this equation now. And the curves of the hyperbola will be opening up and down, not left and right. We just need to find h and k, right? H, k, a, and b. Now the foci are at 1, -10. And again, this will be in a different color. This is not actually on the hyperbola. So there's, I'll just put F1 for focus 1 and 116. Again, this isn't going to be the greatest of drawings, but 116. There's another focus. I'll call it F2 for focus 2. And the curves will be opening around these, right, around the foci. Now the center, right, the center should be simple enough. Let's block this off. The center, right, H comma K, is just the midpoint of the vertices or of the foci, right? If you know where the vertices are, or the foci are, or the co-vertices, you should be able to easily find the center. It's just the point directly in between them. So clearly the center is going to have an x value of 1, and then the average of -2 and 8 is 3. All right, -2 plus 8 is 6, divided by 2 is 3. So 1, 3 is where the center is. And I'll put that here. There's the center. So h is 1, so we're going to have x minus 1 squared in this second term with a negative coefficient. And then k is 3, so we'll have y minus 3 squared in the first term. Now I just need to find a and b. All right, well, once again, a is easy to find. And remember, a is the distance from the center to a vertex. So that's 5 units, right? From 1, 3 to 1, 8, 5 units. Or from 1, 3 to 1, -2. Either way, it's 5 units. So a squared is 25, and that's going to be the denominator under the y minus 3 squared. And then we know the distance from the center to a focus, right? From 1, 3 to 1, 16, or from 1, 3 to 1, -10, that's 13 units, right? So C is 13. Right? C is 13, meaning that C squared is 169. Right? But I don't want C squared for the equation, right? I want B squared. I want that distance to a co-vertex squared. But like last time, right, the relationship between C, A, and B is always the same for any hyperbola. C squared is A squared plus B squared. And I'm putting in 25 for A squared, right? So we have 169 equals 25 plus B squared. Then B squared would have to be 144, right? Subtracting 25 from both sides. And that's a nice one too, right? B would then be 12, right? If B squared is 144. So then from the center, I would go to the right 12 units and left 12 units for those co-vertices. All right, so I'm going to do this instead of, it's going to be a little nuts here, but if I go to the right 12, the x-coordinate will be 13. So 13, 3 is a co-vertex. I'll put CV next to that. And then if I go left 12, that'll be at -11 for the x-coordinate. So -11, 3 is another co-vertex. There's CV again. But again, these are not points on the hyperbola, right? These do not belong to the hyperbola. They are not solutions. They're just guides. Using the vertices and co-vertices, I can make a little rectangle that contains the vertices and co-vertices. And then through the corners of this rectangle and through the center go the asymptotes. This isn't good. Sorry. Again, I knew it wouldn't be the greatest drawing, but here are these asymptotes. And the slopes of these asymptotes, A was 5 and B was 12, right? I went up 5 and then right 12. So the slopes of these asymptotes are 5/12 and -5/12. So this one here has the positive 5/12, but then remember we're using point slope form. It's 5/12 times the quantity x minus 1 and then plus 3. Right? It's basically x minus the x coordinate of the center plus the y coordinate of the center afterwards if you solve for y. So there's y equals 5/12 times x minus 1 plus 3. And then the other asymptote would be y equals negative 5/12 times the quantity x minus 1 and then plus 3 again. So the only thing that would change in these point slope form versions is the slope is positive in one and negative in the other. And now that I have the asymptotes and the vertices in, I can make a very rough sketch. Right? This would be pretty wide curves here. Approaching, just make sure they're approaching the asymptotes, and there you go. These are the two branches, the two curves of this hyperbola approaching the asymptotes as you move further away from the center. But the equation for this hyperbola would be y minus k, so y minus 3, right, the y value of the center is k, squared, divided by a squared we said was 25, minus, and then x minus h squared, or x minus the x coordinate of the center, which was 1 squared, divided by b squared we found was 144, equals 1. And this is what they wanted, right? The equation of that hyperbola in standard form. And once again, I'm going to go to Desmos and enter this and also punch in the asymptotes I found and see if those work out correctly, if the graph approaches these asymptotes as you move further away from the center. All right. So this time the equation I wrote is y minus 3 squared divided by 25 minus, and then x minus 1 squared divided by 144 equals 1. Right. Now again, the center is at 1, 3. Right? We saw the vertices, right? The 1, 8 is a vertex clearly. And here, 1, negative 2, those were the vertices that I was given. I will also plot the center since it's not at the origin, right? 1, 3. So clearly, hopefully it's clear and obvious that this is halfway between those two curves. And then the asymptotes. One was y equals, positive 5/12. It was a over b this time, right? Times x minus 1 times, x minus the x value of the center. And then afterwards plus the y value of the center, right? And that takes you to see this line running through the center here. And then I'm just going to again copy and paste this and just change positive 5/12 to negative 5/12. Right, the other line had a slope of negative 5/12. And I'll make those the same color and dashed. Alright, great. And yeah, it looks pretty good. Alright, and again, if you zoom out, you'll see that the curves of the hyperbola will basically get closer and closer to becoming these two dotted lines. Because they're getting so close to it, you can barely tell the difference. And that looks like that's happening here. All right. So the asymptotes are good. That means, my value of a and b were correct, to find the slopes of those asymptotes. So the equation must be correct as well. All right. And the vertices that they gave me are the vertices that were here. So I think we did pretty good. All right. Great. I'm going to keep doing stuff like this. Alright, so now in this example, we're actually given the center. So h is 3 and k is 5. The center is at 3, 5, and I will start plotting a little tiny picture over here. Right, so 3, 5, there's the center. And they give us one vertex, but if you know where one vertex and the center are, you can use symmetry to find the other vertex. One vertex is at 311. Right. So again, I'll make this a different color because this is actually on the hyperbola. Remember, the vertices are actually solutions. Now, if one vertex is at 311, I'll call this vertices now. The other vertex, That's 6 units up from center, 3, 5 to 3, 11. So 6 units below at 3, negative 1 would be the other vertex. All right, just using symmetry about the center. All right, so the other vertex would have to be at 3, negative 1. All right. And then the same thing goes for the foci, right? They give us one focus. So you see it's at 3, 5, but then, they move up 2 root 10. Right? They add 2 root 10 to the y coordinate of the center. Now 2 root 10, that's the square root of 40. That's between 6 and 7 units. So if I go from here up between 6 and 7 units, that's going to be between 11 and 12. So here's 5 plus 2 root 10, and there's a focus, 3 comma 5 plus 2 root 10. So I'll just call this F1 here. And that's very close to the vertex, but it's not actually the vertex. It's not actually on the hyperbola. And I mean, the other focus then, so I'll just call this foci, would be the same distance below the center. So 3 comma 5 minus 2 root 10 as well would be the other focus. So if I go from 3, 5 down 2 root 10, that's going to be between negative 1 and negative 2 for the y coordinate, 5 minus 2 root 10. So again, very close to the vertex here, but not quite. Right, there's the other focus, focus 2. All right. And again, this should be enough to write an equation. Now, very clearly, based on where the vertices are, right, the transverse axis is vertical. So the equation I'm writing will be like the previous example where it starts with y squared. It's going to be y minus k squared over a squared minus, and then x minus h squared over b squared equals 1. And I know h is 3 and k is 5. Now I just need a and b. Well, we have a. I already used a. Right? A was the distance from the center to a vertex. From 3, 5 to 3, 11, or from 3, 5 to 3, negative 1, that's 6 units. Right? So a is 6, meaning that a squared, right, this first denominator under the y term, is going to be 36. And we know c as well. Remember, c was the distance from the center to a focus, and that's just 2 root 10, right? I went up 2 root 10, down 2 root 10 to get to the foci, or the square root of 40 if you want to write it that way. So that means that c squared is 40. But remember, c squared is a squared plus b squared for all these hyperbolas. And I know a squared is 36, so we have 40 equals 36 plus b squared. Subtracting 36 gives me b squared equals 4. And that means that b equals 2, right, if b squared is 4. So if I was to complete the drawing, the co-vertices would be 2 units to the right of the center, so one's at 5, 5, and I'll put CV for co-vertex. And the other one's 2 units to the left of center at 1, 5, right? There's another co-vertex. So yeah. And then I make a rectangle, going through the vertices and co-vertices here. And then through the corners of this rectangle and through the center goes the asymptotes. Again, this isn't the greatest drawing. I'll go to Desmos in a second. We'll look at a better picture. All right, and then these asymptotes, they're both going through the point 3, 5. So it's going to be y equals, and then this first one that's going up to the right here, it's going to be a over b, right? A over b, because I'm going up a, right b to get to the corner from the center. So 6 over 2, the slope is 3. So y equals 3 times the quantity x minus 3, and then plus 5, right? Using the 0.35 there. And the other asymptote has this equation, y equals negative 3 times the quantity x minus 3 plus 5. It's the same equation, but with just the opposite slope. And I've got the vertices and the asymptotes in. I can draw the the curve should be approaching these asymptotes. Start from the vertex, use the rectangle and the asymptotes as a guide. There's your hyperbola, the two curves of the hyperbola, the two branches. But the equation for this is going to be y minus the y coordinate of the center, y minus 5 squared, divided by a squared, which we said was 36, minus, and then x minus the x coordinate of the center, x minus 3 squared, divided by b squared, which we said was 4, equals 1. There's what they're looking for. Right? And again, I'll test it out. I'm going to graph that and also the asymptotes, plot the center, and we'll see that it works out. Looks good. Right? And it has the same vertices that they told us it should have. Right, so back on Desmos, the equation I just wrote was y minus 5 squared divided by 36 minus an x minus 3 squared divided by 4 equals 1. Right, here, there's one branch, and the other one should be up here. Right? Again, you can see the vertices, right? One's at 311, like they told us, and then the other one should be at 3, -1. Right? The center is at 3, 5. They said that. Right? I'll plot 3, 5. Clearly, that's halfway between these two curves. Then the asymptotes, y equals 3 times x minus 3 plus 5. There's one of them. See how it runs through the center. And then y equals, -3. I should have just copied and pasted it again. Whatever. I'm just gonna. This is quick to type. Okay. Y equals -3 times the quantity x minus 3 plus 5. And again, if you want to put it in slope-intercept form, that'd be no problem. Just distribute the 3 and -3 here and combine like terms. And I'll make both of these the same color and dashed because they aren't actually on the hyperbola. Right? The hyperbola approaches these lines. It's not actually equal to these lines. And it looks pretty good from here. And again, if you zoom out, you'll see that the curves that make up the hyperbola will get closer and closer to just becoming these two asymptotes. Right? They don't actually touch them, but they look like they're basically getting close enough to where it looks like they become the asymptotes. Right? Let's do this. Okay, so looks good. All right. Okay, so now my last couple examples are some pictures given to us, some graphs from the text. So the next one I want to do is exercise 52 from the text. So let's go back to the textbook, and I'm going to scroll down till we get to the exercises. And I want to go to exercise 52. And yeah, here we're given the graph of the hyperbola, find its equation. So again, this is no different than the ones I just did, but now we have a picture, that's all. So we have the center. So all I'm going to do is I'm going to write out, without drawing, I'm going to write out, the centers at 1, 1, so that's the h and k. We have the vertices, which are just the square root of 2 units away, right? 1 plus the square root of 2, comma 1, 1 minus the square root of 2, comma 1. So it's just the center, but to the right, square root of 2, left, square root of 2. And the foci are square root of 5 units away from the center. And that's all we're given, right? And we could find the asymptotes if we wanted or whatever, but this is enough, right? This is what I've had in the last few problems. So I'll just write out the stuff we were given that's in that picture. Centers at 1, 1, so that's the h and the k. The vertices are at 1 plus or minus the square root of 2, comma 1, right? One's with plus root 2, one's with minus root 2. So that tells me that the value of a, right, the distance from the center to a vertex, is the square root of 2. And if that's the case, a squared is just 2. And we're told the foci, right, the foci are at 1 plus and 1 minus the square root of 5 comma 1. And that tells me the value of c, right? The distance from the center to one of these was the square root of 5. So then c squared would be 5. And remember, to write equations, I need a squared and b squared. So this is, a squared plus b squared. And we know that a squared is 2. Right? See, this is no different than earlier examples. So b squared must be equal to 3. And that's all. And then b would be the square root of 3, but I'm not going to draw that. Right? We're just writing the equation. And we saw the transverse axis is horizontal. Right? The vertices are on a horizontal line. They have the same y coordinate. They're right and left of center. So if that's the case, remember when the transverse axis is horizontal, the equation in standard form starts with that x squared term. Right? It's the quantity x minus h squared over a squared. It's always a squared under that first denominator, right? Don't switch those up. Minus the quantity y minus k squared over b squared equals 1. And then I have enough information. I know h, I know k, 1 and 1. And I know a squared and b squared are 2 and 3. So the equation for the hyperbola they gave us was x minus 1 squared divided by a squared is 2 minus, and then y minus k squared, so y minus 1 squared divided by b squared is 3 equals 1. And this is what they wanted, right, the equation. And I mean, you can check it out, but I'll leave this to you this time. Graph this in Desmos and compare it to the graph they give us here. Right, and it should be exactly the same picture, right? It should be. Wonderful. All right, and so my final example for this video is the very next even numbered exercises. Because you can check solutions to the odd numbered exercises in this text. So I'll leave those to you guys. Exercise 54, very similar problem. Right? So we're given a graph, and once again, we have the center, so we know h and k. We have the vertices, right? So we can find a. We have the foci, so we can find c, which will help us find b, and then we'll know the equation. And the transverse axis is vertical this time. So it's going to be that version of the equation where it's y squared over a squared first, right? Y minus k squared over a squared. All right, so I'll write out all the information here again. So we're told the center, right? The center of this hyperbola is 3, 1. So there's the h and k. We're told the vertices, which are above and below this. So it's the same x coordinate. It's just the y coordinate gets added and subtracted to its 1 plus or minus the square root of 2. So once again, a is the square root of 2. Right? The distance between the center and one of these vertices is the square root of 2. So a squared is 2 again. Right? We're told, or we're shown, the foci. Right? At, again, same x coordinate, because it's just above and below the center, so the y coordinate changes, and it's 1 plus or minus the square root of 7. So c, right, the distance from the center to a focus, is just the square root of 7. And if c is the square root of 7, then c squared is 7. And remember, this is equal to a squared plus b squared for every hyperbola. So b squared would have to be 5, right? I'm not going to write the whole equation this time, but you put in 2 for a squared, b squared must be 5. And now I have everything I need, and the transverse axis, the line with the vertices on it, is vertical. Right, and if that's the case, then the equation is going to look like this in standard form: y minus k squared over a squared minus x minus h squared over b squared equals 1, and we have all the information we need. We have the h, we have the k, we have the a squared, we have the b squared. So the equation of this particular hyperbola we're shown would be y minus 1, right, y minus k squared divided by a squared, we said was 2, minus, and then x minus h, x minus 3 squared divided by b squared, we found was 5, equals 1. And there's the equation for all described by that picture. Right. And again, this one I'll leave to you. Type this into Desmos or some graphing calculator and compare it to this picture that was given here, and it should be exactly the same. Right. And maybe plot the center too and the foci, and you'll see it's exactly the same. Great, and that's all I've got for you. So I'm hoping that watching me go through these 5 examples here help you in some way when you're asked to write an equation for a hyperbola that's not centered at the origin on your own. And thank you very much for watching.